Just 48 hours ago, astronomers watched Comet Swan flare up with a surge so violent it broke every prediction. Its tail suddenly fanned out wider than 5 full moons. Then the sun answered back. Out of nowhere, the strongest solar flare in months erupted from a chaotic sunspot region, launching a massive plasma wave, straight into the same stretch of space where Comet R2 Swan is racing toward Earth. Now, with Swan brightening faster than expected and another interstellar object aligning in the same quadrant, scientists are asking a question no one thought they'd ever ask. What happens when a supercharged comet tail meets a solar storm head-on? The countdown to October 21st has begun. And the sky might be about to perform something we've never seen before. September 12, 2025, the first warning. Comet C/2025 R2, now simply called Swan, rounded the Sun at just half an astronomical unit, closer than Mars ever gets to Earth. At first, everything looked routine. Magnitude around 7.4, tail barely 2 degrees long, a faint, predictable visitor. Until it wasn't. Just 2 weeks after perihelion, something inside the comet cracked. September 26, the brightness surge begins. Japanese and Australian astronomers were the first to see it. Swan suddenly jumped almost a full magnitude in a single night, pushing into naked eye territory under dark skies. Forums lit up. Light curves bent off prediction lines. Photos showed a swelling coma and subtle jets erupting from the nucleus. This wasn't a glitch. This was the comet waking up. Thermal stress. Buried volatile pockets. Crust fractures. Whatever happened inside Swan, the result was clear. The comet's engine was open and roaring. Its tail grew to an unbelievable 2.5 degrees wide, stretching across the sky like a cosmic spotlight. For backyard astronomers, this was a dream. For scientists, a warning. A tail built for trouble. Swan's enormous tail became a living laboratory. Dust trails forming a golden fan, ionized gas glowing electric blue streamers, kinks, bends shifting night by night. Every camera, from small backyard telescopes to global observatories, could see Swan changing in real time. And right as the comet entered this unstable state, the sun snapped. September 28, the solar blast at 8:43 UTC, the sun unleashed an M6.4 solar flare, its strongest in months. X-ray detectors spiked instantly. NOAA's Space Weather Center scrambled. SDO and SOHO instruments confirmed a massive coronal mass ejection, CME, erupting outward at 800 to 1000 kilometers per second. Not aimed at Earth, but aimed at something else. Model overlays put its path directly across the region of space Swan was entering, right into its vast, fragile ion tail. Suddenly, a routine comet outburst turned into a possible cosmic collision. Magnetic reconnection, the tail-breaking trigger. If the CME's magnetic field arrives with the wrong orientation, specifically a south-pointing BZ, Swan's tail could literally snap off. This isn't hypothetical. We've seen comets lose their tails before. But never one this close. This bright. And this well documented. A disconnection event can bend the tail like a whip, tear off entire sections, create drifting ion clouds, brighten or dim the tail in under 90 minutes. For scientists, this is a once-in-a-generation chance. For skywatchers, it could be a show unlike anything on Earth. October 21, 2025, the main event. Mark this date. Because the timing is unreal. Swan passes just 0.25 astronomical units from Earth, 39 million kilometers, about 100 times the distance to the Moon. New Moon, the darkest sky of the month. Interstellar Object 3I/Atlas aligns on the opposite side of the Sun. Swan's tail is fully exposed to the solar wind. 2 cosmic wanderers. 1 solar storm. 1 perfect observational window. Statistically, this alignment is almost impossible. But here it is. From the southern hemisphere, Swan will rise early and dominate the pre-dawn sky. In the northern hemisphere, it climbs higher each night as October continues. Even a basic pair of 7x50 binoculars will reveal its full tail in a single sweep. And with the comet so close, parallax, a tiny shift in position depending on where you are on Earth, becomes measurable by amateurs. This is a global skywatching moment. What happens next? Despite all the hype, scientists remain cautious. There is no confirmed link between Swan's outburst and the solar flare. The CME may or may not hit the comet's tail directly. Predictions remain models, not guarantees. But what is guaranteed? This October, every scientist, every observatory, and thousands of amateur skywatchers will have a front row seat to one of the rarest cosmic coincidences of the decade. Comet Swan's story is still unfolding. And the sky is about to write the next chapter in real time. Just